So, hello everyone once again. In this experiment, we are going to perform multi-layer perceptron using PyTorch. So, in this experiment, we will implement a multi-layer perceptron model using PyTorch to classify handwritten digits from the digits dataset available already in the sklearn library. So here, the first question, let's proceed further. As we start, I'll be explaining you what each and every code does along with what we can get an observation from here. So the first question is as it is import the dataset. But here we don't have any .csv or any external file to import. We are importing it from sk.learn datasets and the dataset name is load digits. Once this is done, we are loading the dataset. If you want, I can do this also, for example. I'll try and show you this also. Yeah, this is the data. This is only for reference whether our data is loaded properly or not. That's the observation which you can get from here. And for question number 2, in this step, we define the independent variables x and independent variables y. The input x contains the pixel values of the images and the y contains the target labels representing digits from 0 to 9. Question number 3, standardize the input variables using standard scalar. So here, this ensures that all the input features have mean equal to 0 and standard deviation equal to 1, which helps us improve model performance. And question number 4, split the data into training and testing. Yeah, here what we are doing is we are training and testing the models. 80% of the data is tested and 20%, sorry, 80% of the data is trained and 20% of the data is tested. And that's what's here. Testing is for 20%, remaining 80% is for training. Next, we have convert the data into PyTorch sensors. In this step, we convert the training test and testing data into PyTorch sensors. This is necessary because PyTorch models requires tensor format for computation. That's the reason why we do this. The next thing is very important thing, which is defining the MLP model. Here first, the model consists of hidden layer with sizes 128, 64, 32 and 16. Here we are using ReLU activation function. You can see here. With this activation function is used between each layer. So finally, the output layer contains 10 neurons from the digits 0 to 9. That's the understanding which we get from this particular code. Here, basically, what we're doing is that we are defining the MLP model. That's what is happening here. In question number 10, the we are training the model using backpropagation, which means we use cross entropy loss as the loss function and Adam optimizer for optimizing the weight. And as you can see, the learning rate is 0.001. We are using 100 epochs, which means that the data is being trained for 100 times and the training error is recorded in each iteration. That's what we do here. The next one is plotting the curve. So we are plotting the curve which shows iteration versus training error. This graphs helps us to understand the model error decreases during the training. So as the error, you can see the error was starting so much high. As we train it 100 times, it's decreasing. That's which means that the model is being trained very well. It's a good model. And next one is test the model. Here after training the model, we use it for testing it. The trained model, they predict the digits classes for each test sample. That's what is happening here right now. And the next one is evaluating the model. We finally evaluate the model using performance metrics. So we have confusion metrics and accuracy and precision, recall and F1 score. So the model has achieved 95% approximately, indicating the model performs really well in classifying handwritten digits. So in conclusion, that we have implemented a multi-layer perceptron using PyTorch to classify handwritten digits. The model was trained using backpropagation and achieved a very high accuracy with good performance metrics. Thank you.